Okay, so what exactly is reduction? Okay, reduction is when essentially your charge becomes more negative. Okay, how does somebody's charge become more negative? You gain electrons. Okay, there are obviously a lot more, there are other definitions for reduction, but for the purpose of today's notes, this is all we need to know. Okay, oxidation is the opposite of course, right? Your charge becomes more positive. Becomes more positive. Okay, in other words, you lost electrons. Are we okay? Can I? Okay, so being more positive means you lose electrons, being more negative means you gain electrons. That's all. Can? Okay, for electrolysis, okay, our focus is on using electricity to break down or decompose a compound. We have seen the term electrolysis before. Okay, anyone can remember when? QA? No. Reactivity series. We have seen it in reactivity series. Okay, to be more specific, which part of reactivity series? Okay, electrolysis is the method to obtain or to extract, okay, the reactive metals. Okay, who are your very, very reactive metals? Your sodium, your potassium, magnesium, CaAl. Okay, if you all remember, when you are going through your reactivity series, okay, there are the top 5 guys, you cannot use carbon to isolate. Correct? We have to make use of electrolysis because he's the only method that's powerful enough to obtain these pure metals. Following? Good. Okay, especially my focus for today will be on those who have never done this topic before. Okay, so for the ching chongs, just bear with me for a moment, can? Okay. Okay, so let's talk a little bit about electrolysis. Okay, we are going to make use of a compound, an ionic compound, okay, preferably containing the metal I want to isolate, okay, in molten or aqueous state. What exactly does this molten or aqueous state part tell you? What do I require if I need an ionic compound in molten or aqueous state? Hey, madam, what time already? How? Mobile ions, exactly. Okay, mobile ions. Alternatively, we can say I need to be able to conduct electricity lah. I need conductivity for your electrolysis process to happen. Have you guys done this topic before? Okay, focus up. Okay, so for your electrolysis process, we will rely on your mobile ions, because I need to be able to conduct electricity. How exactly does this happen? Okay, your electrolytic setup looks like this. You have a simple battery. Okay, you have a battery, you have electrolytes, and you have electrode. What exactly are all these things? Okay, battery, I hope I don't have to go through. Okay, for the bio students, the long line means positive, short line means negative. Okay, and for bio students, plus means positive and minus means negative, can? Sorry, I don't know whether you all know, I must cover all my bases, you know. Okay, so anyway, alright, so you have your positive and negative terminals, and you have your electrolyte. Let's talk about the electrodes first. Electrodes, right, essentially are just rods, made from a variety of different materials. They are conducting materials, that provide surface area for your redox process to happen. You have a surface area for your redox process to occur. Most of the time, we will make use of either graphite or platinum. Tetra, why graphite? Why cannot use just normal carbon? What is it about graphite that helps me in this setup? No? It is, yes, it's from chem bonding. What about it? Sure, giant covalent structure, okay, yes, hexagonal, whatever. Okay, I thought you were going to say electrically conductive. Graphite is the only covalent compound that can conduct electricity, isn't it? Because of your delocalized electrons between the layers of carbon atoms. Can I remember? Okay. Or alternatively, I can use platinum lah. Platinum, as far as we are concerned, is a useless dog. Okay, unreactive is the term that we use. In other words, your electrode should not take part in the reaction, ideally lah, okay? Prevent the reactions within the electrode. I want my electrode to be useless because I want my redox process to happen at the electrode, on the surface. Okay, your reduction and oxidation should happen on the surface of the guys. Following, people? Kaylin, okay? Kai? Wala? Good? Katie? Farah? Ken? Kenna? Okay? Now, this is the electrodes, okay? These are your rods, okay, that will facilitate the reaction. Then we come across the electrolytes, okay? I will skip this part temporarily, okay? Just give me a moment. Okay, let's talk about the electrolyte. You are able to conduct electricity because of free moving ions. This is your ionic compound. Your electrolyte contains the metal you want. He contains the metal that you want. Okay, i.e. if I want sodium, I will contain maybe sodium chloride, okay, or sodium oxide, or sodium whatever. Okay, the point is I need to have that correct ion. Okay, some electrolytes that we will go through, okay, we have strong, we have weak, and we have non-electrolytes. Okay, your strong electrolytes are those that dissociate completely. Fucking a lot of ions, because I dissociate 100%. Every single mole splits. Alright? Okay, case in point, strong acid, your strong bases. Okay, all of these guys, 100% dissociation. Correct? Okay, if I completely dissociate, I have an abundance of pluses and minuses to facilitate my redox process. Okay, seawater is an exception. Okay, he's a mixture, right? Okay, but he's a mixture that contains a lot of ions. He contains a lot of ions. Alright? So he is very, very good as an electrolyte. Conversely, okay, we also have weak electrolytes that dissociate partially. Okay, case in point, or your weak acid, your weak bases, okay, your dissociate like 3-4% kind, bloody pathetic one. Okay, tap water also, not a lot of ions, not a lot of ions within tap water. Okay? And then we have our non-electrolytes, which completely don't conduct electricity. Okay, like this fella is a freaking covalent compound. Okay, you cannot conduct anything. Okay, alcohol, sugar, all this, yeah, you can form liquid lah. But what's the point? There's no ions. They learn following? Okay? So, ideally we want to have strong electrolytes. Now, let's go to the process. Okay? If you want to, you can flip to the next page, although I think it would be better for you guys to just listen to me. Okay, so I have positive terminal, negative terminal. That also means that this electrode will be the positive electrode and this one will be the negative electrode. Agreed? Okay, in physics terms we say, okay, this is the electrode with your positive potential. Okay, you all learn potential difference, right? This is it. Alright, so when you have positive and negative electrode, remember what your electrolyte is, okay? He is an ionic compound, which means you should have some pluses. Okay, I'm just going to draw a few, maybe 3 of each. Okay, then you have minuses, minuses, minuses. Can? Okay, draw first. Then I'm going to explain everything. Which part? Your electrolyte is an ionic compound. Ionic means I got cation and anion. Agree? So I must. The one that's connected to your positive terminal will be your positive electrode, yes. Are we okay? Okay, now what I'm about to say, okay, don't copy first. I want you guys to listen to me. I'll give you time to copy afterwards, okay? Okay? Because this process, right, if you look down, you write, you look up, Go be a bunch of fucking symbols, then you don't know what they mean. Okay, you'll see later what I mean, what I'm talking about. So, if you are positive, will you go towards negative or positive? Right? If you are the positive ion, will you go towards a negative electrode or positive electrode? If you are positive. Okay? Negative, right? Your unlike charges will attract, north and south pole attract, you plus and minus will also attract, agree? Okay, so all of the positive idiots, okay, this fella, I say again, don't write first, I'll let you guys write later, okay? We'll go this way. Correct? Okay, then you have your negatives, which will obviously get attracted to the other side. 对不对? Okay, so Dylan, can you tell me, if you are positive ion, do you want to become more positive or more negative? You already have a positive charge. Do you want to become more positive or more negative? More negative, right? You want to eliminate your charge, you want to be stable. True? Okay, so if you are positive, okay, all of your positive ions are going to come here and undergo reduction. Because as positives, you want to become more negative. Correct? Okay, which means the reverse is also true lah. All your anions will come here and get oxidized. Following? If you are negative, you want to become positive. If you are positive, you want to become negative. Clear? Now, during your oxidation process, okay, just now I went through the recap on redox, alright? So, during your oxidation process, you are losing electrons. Where do you think these electrons are going to go? Okay, these electrons are going to be released over here, okay, released at this point, and then they are going to float up your wire. Go, 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 go. Flow, 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 flow. Flow, 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 flow. Here. What's happening here? Reduction, right? All your cations will come here and accept the electrons that have arrived from him. Understand the thing? Okay, it's a whole process one. So your anions go to the positive electrode. Okay, then they lose electrons. Your electrons flow through the wire, come here where your cations are eagerly waiting to gain electrons and get reduced. Clear? Can? Okay. So, last but not least, okay, chemists are not very creative. Okay, here I have an electrode that attracts your anions. Correct? Okay, electrode that attracts anions, we call him anode. Make sense? Okay, then electrode over here attract cations. We call him cathode. Your cathode will be where reduction happens. Your anode is where oxidation happens. Questions? If not, you guys can start writing. Okay, there's a lot of things that I said, so try to remember. Okay, you can ask questions along the way. I'll ask one time. Anybody need me to repeat the process? So you understand the fact that negatives will go down there to get oxidized, right? Okay, because they want to become more positive. How does one become more positive? You have to throw away negativity. You have to lose electrons. Agree? When you lose electrons, those electrons are going to go along the wire. They will travel along the wire, come down here, where your cation ions will be waiting. You are positive. You want to become more negative, you have to gain electrons. The pole? Yes. So your reduction process over here, right? Okay, the cation ions will gain electrons. And the electrons come from where? The electrons came from the anions that got oxidized over there. Clear? Dylan, good? Hi, okay? Can? Okay, so this is your electrolytic process, okay? Anyone have finished writing it? Okay, good. Let us carry on. Okay, so what we did is essentially explain everything over here. Okay, so I'm going to skip point 1 and point 2. Alright, if you want to, just take a quick read. Okay, if you want to highlight whatever, go ahead. Current flow from positive to negative, electrons flow from negative to positive, blah blah blah. Cation ions flow to negative electrode, undergo reduction. Anions flow to positive electrode, undergo oxidation. That's all. Okay? So, at the electrode surfaces, this is where we start to consider something important. Electrode surfaces, these ions will lose their charges and become neutral particles, either atoms or molecules. Okay, what are some examples of molecules you can possibly obtain? Maybe O2, H2. Okay, all of your diatomic compounds, all of your diatomic molecules don't exist as normal atoms, agree or not? Okay, so you have to combine them together. Cl2 is a very famous example as well. Okay, they exist in their molecular state. You cannot have the atom produced by himself. Can? Okay, Some of your schools, when they are finally going through this, will help you guys remember it as crow or whatever shit. Okay? Cathode is for reduction. Anode is for oxidation. Whatever lah. Okay, find your own way to remember K already. Doesn't really matter what acronym you use. Okay? Good? Good. So, here is where some QA stuff may or may not come in. Okay, because of the production or the use of certain ions and products, okay, we can have changes in color. We can have bubbles for effervescence. Okay, better word would be effervescence. Okay, if I form pure metal, I may also have this thing called deposition. Okay, a metal deposit. Or the anode himself can react. Okay, anode himself, okay, reacts. How exactly does this happen? Okay, we will talk about him later. Question? Good. Well, good. Hey? Okay, Kara? Kara? Now, let's talk about a simple electrode. Oh, sorry. The anode himself reacts. By the way, right, you all use iPad one, right? Is there any way to get rid of these these things? What the oh wait, do I have to do that? Bro, what? What the fuck? Okay, anyway, you all got see the dotted shit, right? How do you get rid of it? Huh? No, I'm not. I switched already, bro. I have upgraded. Wow. Thanks. Except for my fucking watch. See? Come back again, bastard. Okay, what? Okay, honestly, I have no idea how to get rid of this, so you will see like random ones here and there. Okay, I apologize in advance, I don't know how to get rid of it. Okay, come. So, for a simple electrolytic cell, Okay, I say again, molten or aqueous electrolyte. We will first label your battery plus and minus. One side plus, one side minus. Then you can also take this opportunity to label the electrodes. Positive electrode connected to positive terminal and vice versa. Then you write down the ions that are present. This, okay, is generally very, very effective, okay, because it helps to, keep track. Okay, you keep track of the ions so that you know who goes where, which ions are going to which electrode. Okay, I give you guys an example. So down here we have NaCl. Okay, the 3 to whatever, we explained it already, so I won't worry too much about it. Okay, your electrolysis of a molten sodium chloride compound. What does molten mean? Michelle? Do I have water? Liquid, but do I have water? No water. Okay, molten comes from the word melt. Okay, so when you melt your salt, okay, you will get the molten version of the ionic compound. In other words, this whole setup, right, must be at a very high temperature because your NaCl must be kept as a liquid. The moment he solidifies, the whole setup is gone because ionic compounds in solid state cannot conduct electricity. Correct? Correct? No? If he solidifies, my mobile charge carrier is gone already, how to conduct electricity? Hello? What? Which part is no? Okay. You didn't know that in solid state ionic compounds cannot conduct. Okay, now you know? Okay. In solid state, your ions are stuck in your lattice position, you vibrate only, they cannot move. How to carry current from one point to the other? Correct? Okay, so they have to be aqueous or molten. Alright, so when you label, okay, positive terminal, negative terminal, okay, down here positive, down here negative. In between, within your electrolyte, you have Na plus and you have Cl minuses. You don't have to draw 3 of each, okay, because I just need 1 to show who's going where, right? Katie, where's your Cl minus gonna go? Left or right? Yeah. Agree. This fella is gonna go here, and this fella is going to go here. Correct? Okay, if you have your Cl minus, okay, he will come to your positive electrode, undergo oxidation because you are negative, right? You want to become more positive, correct? So you lose electrons. Lose electrons. And these same electrons are going to flow through the wire as we mentioned already. Okay, all the electrons are going to flow through the wire to your Na plus, who will happily gain the electrons to form liquid sodium metal. Are we understanding each other? Yes? Okay? So, can. Okay, so what's going to happen right now, right? Okay, apart from just getting your different charges, okay, we must also do balancing. Okay, those of you that have done redox before, okay, you all have a name for this fella and this fella. They are called half equations. Okay, when you merge half equations, you must make sure that the electron numbers balance out. What exactly do I mean by this? Let's go through. Okay, so on the left side, I have 2 Cl minus to give you Cl2 and 2 electrons. No worries. Okay, on the right side, you have Na plus 1 electron to give you sodium metal. Correct? Yes, yes. Okay. Kaylin, what can I do to the equation such that I can get a proper chemical formula here? Down here got 2 electrons released. Down there only uses 1. What to do? I need 2 times 2 here and times 1 here. Okay, get it in your heads now. You cannot have spare electrons. If I release 2, I must use 2. So in other words, the reaction happening at your cathode happens twice as fast as the reaction happening at your anode. Understood the thing? Because you simply need to use up the electrons. There is not an option, there's no choice one. Okay, so when I write out my final formula, right, it will still be 2Cl minus, because this one times 1 only ma. But now I have 2 Na plus ions. Okay, you can go ahead and write your electrons if you want to. Okay, plus 2 electrons here, that's fine. Then my products will be Cl2 gas, as mentioned, and 2 sodium atoms. And I also have 2 electrons. Okay, but your electrons appear on both sides. There's no point keeping them in. Correct? Yes, no? Because the balance on both sides, if both sides plus A, you also cancel out, right? Okay, so I don't have to bother writing my electrons. We have already balanced it. That was the whole point of timesing 2 here just now. So, in other words, your 2Cl minus and 2Na plus can just be written as 2NaCl straight away, which is what we did. And then you have 2 sodium liquid and 2 Cl2 and 1 Cl2 gas. Okay, however, just take note, guys, okay? A student from the Monday class asked, hey, how do I know that sodium is a liquid? Isn't your melting point of sodium metal fucking high? To which, yeah, the sodium metal melting point is very, very high. But if this whole setup is hot enough to melt your ionic compound, you can be very, very assured that it is hot enough to melt your metal. Clear? Good? Okie dokie, yes? Can That's right, okay now? Sure. Okay, good. Okay, so down here, there's just a note here. Go ahead and read through if you want to. I'm not too concerned. Okay, the important thing is we understand you cannot be solid. Okay, your solid state won't work. So your ionic liquid contains free moving ions that can act as mobile charge carriers. Finish. Are we okay? Okay, I give you all 5 minutes. Okay, take a read through what we just did before I move on to the next page. Okay, really read through and understand why some ions go to different places, what happens once they are there. Any questions, guys? What? Kara, what? What you want? Why? Are you okay so far? Sure. Yes. Yes. Calcium is higher than sodium. What's your school? Shut up lah. Since when calcium higher than sodium? Yeah. But to be honest, they are not going to test calcium versus sodium. It makes no sense. Those on top, right, they won't compare against each other. Because all of them are actually around the same reactivity. So yeah, won't really worry. Are we okay, people? Yes, no? Good? Good. Okay, come. Let's talk about something else. Okay? So, are you okay? Are you okay? What are you complaining about? What's wrong with Chem WA? Fuck WA, man. Who cares about WA? It doesn't even It doesn't even count towards your final score. So fuck it, man. No, they will use your prelims as a balance, not the WAs. They cannot go so far back. Okay, molten is very, very easy because only have one cation and one anion. Right? Okay, so there is no issue. Your positive go to negative electrode, negative go to positive electrode. Finish. Okay, the issue is if I have aqueous solutions. Aqueous means what? Means got water. Water means what? Water means I introduce H plus and OH minus. In other words, these two guys are competition. Okay, taking the previous example into consideration, if you have sodium chloride, your Na plus now has a competitor, which is your H plus. Or both positive, so both will go towards your negative electrode. Who takes priority? That's what we call selective discharge. Okay? So, okay, we say selective discharge or preferential discharge, okay, of your ions. So, how exactly does this work? Okay, the electrolyte will contain everybody. Okay, that's the issue. How do we determine who wins? Yes, Jonas? I don't have this thing one. Cannot be, bro. Okay, wait.
It doesn't say equals or like you're missing that one line.
Oh. Okay. Feel free to write it in.
Why don't you so shit?
Complain, bro. Google reviews. Go and complain. Okay, anyway. So, okay, let me teach you guys a little hack, okay, that we will use. Okay, when your school goes through this, okay, you can feel free to use this hack as well. It will make things a lot easier. Okay, what exactly is the hack? Okay, who wins? Okay, the hack decides who wins. Pedro, are you okay? See my little sleepy buddy. Do you want to stand up? Good, sure. Okay, so how do I determine who wins? Hear me out. Okay, for cations, okay, H plus wins unless metal is less reactive. Okay, your H plus wins unless his competitor is less reactive than him. In other words, who are the people who are less reactive than hydrogen? Well, give me one, just one. Who is less reactive than hydrogen? On your reactivity series, come on. All of your useless people. Cu, Ag, Au, all these all pathetic one. Right? Okay, but here they win because they are less reactive. We say preferentially discharged. Good? Okay? Next, your hack for the anions. Even easier. Okay, the cations one rely on reactivity series. The anion priority, okay, depends on concentration. OH minus wins unless it is a concentrated solution. Okay, think about it, guys. If it's very concentrated, I have a lot more chloride ions than OH minus. The chance of your Cl minus reacting is very high. Agree? Agree? Okay? So, for cations, your H plus wins unless you are useless metal. For anions, your OH minus wins unless concentrated. There is a caveat that we have to keep in mind for your anions, which is your sulfate and your nitrate will never be discharged. Okay, they will never be discharged. We say that they are stable anions. Reason behind it, not in syllabus. Okay, A levels also won't touch why they are never discharged. Yes? Because it's about reactivity, it's not about concentration. It doesn't matter how much H plus ions I have. Correct. Yes.
Why is it not like more reactive than
Very good question. Okay, so another student asked this just previous day as well. Okay, why if more reactive, okay, you will lose. Isn't more reactive more likely to win? Okay, what does it mean to be reactive, Kaylin? For example, I give you K versus Cu2 plus. What's going to happen? K will displace, right? So you end up getting K plus and Cu solid. Agree? Okay. So to be reactive means I will give you the electrons, ma. Correct or not? If I'm more reactive than you, I will give you the electron. I take away your positive charge. Agreed? So now I have like potassium versus hydrogen who is less reactive. Your potassium will want to stay in this form. Okay, what it means to be reactive, right, for metals is, if I'm very reactive, I want to lose electrons. It doesn't mean I want to gain them back. Good? Okay, to be reactive as a metal means you are very willing to lose electrons. You are not willing to gain it back. Clear? Sorry, I didn't hear that. What? Win means you get preferentially discharged. So, for example, let's say, just now the example we had was Na, right? So, will this happen or will this happen? Our answer is, this one happen, not him. Only after I completely run out of H plus, then he will have his turn. That's why we say preferentially discharged. I have both, but who will take priority? Hydrogen. Okay, so with that in mind, guys, okay, please do not forget these hacks, alright? It will be very, very useful to you. And another two things that you guys are going to have to remember. Okay, if H plus win, what is the equation? What is the half equation for hydrogen? Okay, hydrogen one very easy. Because what can H plus possibly form, Michelle? H2, right? That's the only fellow that contains hydrogen and hydrogen only, ma. Right? Balance. And H plus is positive. You want to gain electrons to become zero. This is your equation for hydrogen winning. For hydrogen undergoing selective discharge. Okay? Can What up? Good? Good. If hydroxide win, this is the annoying one, okay? For now, I will let you guys refer to it. Eventually, you all shouldn't need it anymore, okay? It is 4 OH minus to give you 2 moles of water, 1 mole of oxygen, and 4 electrons. Okay, go and memorize these two. Hydrogen one very simple lah, but the bottom one more important. Can? Are we okay? Are we okay? If we are okay, let me give you guys an example of this scenario. So, same compound, sodium chloride, but now you are aqueous state. If you are aqueous state, okay, this is what's going to happen. Within this NaCl aqueous, you have Na plus, you have Cl minus, you have H plus, and you have OH minus, the new guys now, right? Because aqueous ma? Okay, so, did I say it's a concentrated solution? Never say concentrated, right? Always assume dilute. If they never mention anything, we are going to assume that it's a dilute solution. And if he is dilute, that means this guy wins. If he's concentrated, your chloride will win. Ken? Ken? Are you okay? Okay, Then, Na plus versus H plus. Kara, who takes priority over sodium or hydrogen? Who will win? Who will be preferentially discharged? As Na plus or H plus? Na plus, H plus. See, I read the same way that you don't know, right? What way? Okay, hydrogen will take priority because he is less reactive. Kara, do you copy down the hex? Do you understand the hex? I don't think so. Okay, hydrogen will always win unless the other guy is less reactive than he is. Understand? Okay, sodium fucking reactive he most likely won't win one. So, where your respective electrodes, your OH minus will react, okay, to form your H2O and oxygen and electrons undergo oxidation. Yeah? Okay, then at your negative electrode, you'll attract your cation to form H2, undergo reduction. Simple? Now, again, if I'm combining the equations together, 4OH minus to give you 2 moles of water, oxygen, and 4 electrons. The other guy is 2H plus 2 electron to give you H2 gas. Dylan, what do I need to do to these equations? To top or bottom? Okay, you must balance your number of electrons. So this guy will times 2, this fella times 1. Overall, I get your same 4OH minus, but now your H plus is double, correct? So you plus 4H plus instead. True? True. Okay, then you get 2 water, you get 1 O2, and you get how many H2 molecules? Teja? 4. Really? 2? Which one? 4, 2. Or 1? 2. Okay. Down here I already have 1. I times 2. You just get 2 H2 molecules. Okay. Are we good so far? Okay. Now, if I have, okay, don't have to write this down. Okay, if I have H plus OH minus, give you 1 H2O, right? Right. Okay, so if I have 4 H plus and 4 OH minus, how many water will I form? Let me repeat my question. 1 H plus, 1 OH minus gives 1 H2O. So 4 H plus, 4 OH minus gives you? A plus B give you C. 4A plus 4B give you how many C? What? 4C lah, dey. 1, 1, 1. So 4, 4, 4. Very difficult, man. Difficult? Siao. Okay, so in other words, that whole left side, your 4OH minus and 4H plus, can just be written as 4H2O. To give 2H2O plus O2 plus 2H2 molecules. Correct? Okay, now, voila. Left side 4H2O, right side 2H2O. What to do? Times 2. Times 2 where? No lah, siao eh. Down there 4x, down here 2x. You're not trying to balance anything anymore. This equation is already balanced. But would you write like 4x equals to 2x plus 6? Or will you just write 2x equals to 6? Your x's on both sides can cancel out one, bro. You get rid of this, you can change this number to 2. 4H2O equals to 2H2O plus some other shit, right? I shift my H2O to the left side lah. That is 4 minus 2 ma. Yeah? Okay, which explains why the overall equation is like this. Okay, 2H2O to give 2 moles of hydrogen and 1 mole of oxygen. Are we okay? Agreed. We are cancelling out the repeated one. Down here 4, down here 2. If you cancel the 2, down here left with 2 only ma. Okay, well. Yes, Jaden, what?
Yeah, but then won't the mole ratio be different?
The mole ratio be different? It won't.
Other elements, other products.
It won't, because your H2O should be already over there. I started with some water, I ended with some water, ma.
Now with this, right, the mole ratio for P2 to O2 will be 1.
No. Yes, but at the start it wouldn't have been 4 to 1 in the first place because of him. Him being here means that the equation is not actually balanced yet. I need to get all my same people on one side first. If I have both same side, I cancel already, ma. Why would I include him? Are we okay, people? Yes? You all look a little bit tired. Okay, let's wrap this up. Okay, I give you all some questions and we go for a break. Can? Can, Now, possible question. Okay, why is hydrogen twice that of oxygen? Okay, of which you tell the marker, hey, fucking open your eyes lah. 2 mole to 1 mole. Right or not? Okay, 2 mole to 1 mole for gases is the same as volume double, ma. Okay, for every 4 moles of electrons transferred, I form 2 H2s and I form 1 O2. Correct. What did I say? Then you're not. 4 moles of electrons, right? Okay, I form 2 hydrogens and 1 oxygen. So by Avogadro's law, anyone can tell me what's Avogadro's law? No. No. What's Avogadro's law? Yes. N equals to volume over 24 dm3. Can you remember? Can I remember? Go ahead. 6.02, that one's Avogadro's constant. Not applicable here. I'm not asking about number of particles, ma. I want volume. Okay, since mole ratio is equal to volume ratio, please guys, when we give you guys mock papers next time, you better write this one. Okay, you better write this one. Instead of saying by Avogadro's law, you can say by number of mole equals to volume over 24. Can. Okay, or by, by mole equals to volume of gas over 24. Since the mole ratio is, then the mole ratio is whatever. Also can. Okay, instead of writing Avogadro's law, you can just write this. In other words, you input the formula into your answer, into your structured question. Okay, so if mole ratio is 2:1, volume ratio will also be 2:1. Can? Good? Good. But then, okay, always followed up with this stupid question, okay? Instead of 2:1, it is not exactly 2:1. Okay, maybe if I have H2 to O2, right? Maybe down here I got 100. I'm supposed to get 50, correct? Correct? But I don't get 50. I get maybe something like 48 or 47. Because what? Because some oxygen dissolves in the water. Right? That's how your fucking fish breathe, what? That's how your fish survive, isn't it? That fish survive. They will say suggest why the volume ratio is not exactly what it's supposed to. Nope, not about MR. It's just about solubility, which we won't touch yet. Okay, so what's observed at the electrodes? I produce gas, right? Okay, so you have effervescence on both sides. Can? Okay. No, you do not. If I ask what's observed, just say effervescence. How will you know what is observed? How will you know what is produced? Colorless, odorless gas? How do you know it's hydrogen? You will say effervescence, but you cannot tell there's hydrogen. No, but if they ask you what's observed, how can you like see, oh yeah, bubble means hydrogen? Cannot what? Like sodium chloride, liquid or what?
Aqueous.
You cannot tell the identity of the gas. So you cannot say that there is effervescence of what. Especially if they ask you observe. How do you observe? The only thing you see is bubbles. How you know what's the bubbles? I mean, we know lah based on chemical equation lah. But based on observation, you can see meh? Don't siao eh. You confirm cannot tell it's hydrogen and oxygen one.
That's hydrogen.
Yeah, but you cannot see it.
But actually it's hydrogen.
Correct. But you cannot say that that's what you see mah. Yep. This is only for NaCl. This is for as long as H plus and OH minus are the ones that win. Guys, okay or not? The two of you? Good. I'm going to give you guys some questions. I'm going to give you all questions. Okay? Come. Okay, as some practice for y'all, what I'm going to do is I'm going to provide the electrolyte. You guys are going to give me the anode reaction and the cathode reaction. Okay, I will give you guys an example of what I mean. Okay? So, let's say for the electrolyte I use aqueous MgCl2. Example. Okay? Aqueous magnesium chloride. Let's make this a little bit more interesting. Aqueous magnesium chloride, concentrated. Okay, he is a concentrated MgCl2. Alright? Now, hear me out first, guys. Okay, don't try to do anything yet. If you guys need to, flip back to the previous page and look through the hacks. Okay, when does hydrogen win? When does hydroxide win? Okay, for your oxidation, who is going to win? Will it be Cl minus versus OH minus? Kara, who wins? You can refer. I have a concentrated solution of magnesium chloride. Cl minus will take priority. So my oxidation equation looks like this. I have Cl minus, and I'm supposed to form Cl2 gas because it's a fucking diatomic molecule, right? Okay, so balance. But then remember, it's oxidation ma? So you are releasing electrons. Electrons should be here, not there. You are not gaining, you are losing. Correct? So you plus 2 electrons on this side. I pause first. Anybody lost it? The equation is not going to be given to y'all. Okay, y'all need to know who are the diatomic people. Y'all need to know when are they going to react and when are they not. Okay, for reduction, okay, it's going to be Mg2 plus versus H plus. Kaylin, who wins? Hydrogen takes priority because he is less reactive, right? So you have 2H plus, which will gain 2 electrons to form H2 gas. Okay, don't have to write the full equation. I just want to see whether you guys can get your anode and cathode. Ready for more examples? Okay, I'm going to shoot about 3 or 4. Let's go. Dilute sodium sulfate. Concentrated aluminium sulfate again. Molten magnesium bromide. Okay, write the examples down first. Okay, later on y'all can go ahead and do the anode cathode reaction. Okay, one more. Okay, never mind. This is it. Just these three. Okay? Give me the anode reaction, give me the cathode reaction based on your knowledge of who takes priority. Okay, try.
Don't need to put overall equation, right?
Sorry?
Don't need overall equation, right?
No need overall equation. Okay, I find P1 and C so far. Okay, good. Carry on. Everybody knows that sulfate doesn't get discharged. I don't know. I just want the person to do it.